As a second example, let us look at the model of this tipper damper. Here, the input motion is linear provided by a hydraulic actuator, and this linear motion has to be transformed into a rotary motion of this dumping bin. Thus, the linear motion at the hydraulic actuator from the input side is transferred to the bin and is also transformed into the rotary motion. One more point one needs to watch in this machine is that during the dumping position, the damper is locked and cannot be disturbed by any accidental disturbance. Of a mechanism, let us look at this one, which is a windshield wiper mechanism for bigger vehicles like a bus. Here, the continuous rotation of the drive motor is converted into to and fro oscillation of the wiper blade. Of course, the power available at the motor shaft is used to overcome the friction force between the blade and the windscreen. However, designer is primarily interested to ensure a proper range of oscillation of the wiper blade to generate the desired field of wiping. Consequently, we do not call it a wiper machine, but we call it a wiper mechanism. As a second example, let us look at this common pair of pliers. Here, if we want to study the relative movement between the two jaws, we can hold the lower jaw fixed and move only the upper jaw. As we see, these two jaws are simply hinged and the axis of the hinge is passing through this point. Consequently, all the points of this upper jaw are moving in circular arcs centered at this hinge axis. Consequently, it will not provide a very good grip on a flat object, and especially so if the object is long. However, we can design a parallel jaw pliers by using a suitable mechanism. Using this mechanism, as we see, the upper jaw is moving parallel to the lower jaw, and consequently it will provide a very good grip on a flat object. So in such mechanisms, the generation of the specific motion characteristics is of primary interest rather than the forces or torque involved. As an example of a single degree freedom mechanism, let us look at this model of a tipper damper. This has 5 moving links and 1 fixed link, which is the body of the damper. Here, the input motion is provided by this hydraulic actuator, which tilts the damper bin. Here, the linear motion of the actuator is being converted to the damping motion of the bin. This has single degree of freedom. What it means that for a given input, say this much, this position of the damper bin is unique. We cannot change anything so long we do not change the input motion. In other words, for this input motion of the actuator, only one of the 3 independent coordinates of the damper, that is x, y of a particular point and the rotation theta, only one of these 3 variables can be specified. Other 2 are automatically fixed. That means I can take the x coordinate of this particular point of the damper anywhere, and accordingly the input is decided what is needed, but y coordinate and theta, that is the orientation of the damper bin, are automatically decided. As an example of a 2 degree of freedom mechanism, let us look at this model of a front end loader. This mechanism has 8 moving links, and the fixed link is again the body of the machine. This is the second link. If I call that as the first link, the body of the machine, that is the fixed link. This is the second link. This is the third link, fourth, fifth, sixth, seventh, eighth, and ninth. This output bin is the link number 9. Here we have two independent inputs provided by these two hydraulic actuators. Since it has 2 degrees of freedom, I can control 2 of the coordinates of this output bin. Say x coordinate of a particular point and the rotation theta or the orientation theta of this output bin by controlling independently these two input motion. We might noticing that this movement is not changing the orientation of the bin so much, it is mainly changing the y coordinate of this particular point. Whereas if this input motion is provided, this point is not moving so much, it is the orientation of this bin which is being primarily controlled. So this is an example of a 2 degrees of freedom mechanism with 2 independent inputs. That is why this is also a constant mechanism. By that we mean if we fix up both the inputs, then the output bin takes up a particular location and orientation. As an example of a mechanism with 3 degrees of freedom, let us look at this model of an earth moving machinery. Here again, link number 1, the fixed link, is the body of this truck, and there are 11 other moving links, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. This 12th link is the output link of the bin of this earth moving machinery. There are 3 hydraulic actuators, that means there are 3 prismatic pairs here, rest of the pairs are all revolute pairs. As these 3 hydraulic cylinders are moved, the output bin can be moved in this plane of motion. In fact, there are 3 independent inputs, so all the 3 motions, that is 2 translation and the rotation,